This is the first foldable for section 6.1, and what we're doing today is graphing system of equations. What that means is that we're going to be graphing two lines in one coordinate plane. We're first going to look at what it means to be consistent and independent. Consistent means that there is one solution. And independent means that there's one solution. I'm sorry, so consistent means that there is a solution, at least one, and independent means that there's only one solution. So let's take a look. In my foldable, I tend to call the first equation y1 and the second equation y2, and that's how I label it. So we're going to start by graphing it. The first one says -1. So we start at the -1, go up to 1, 2, and 1 to the right. The other one says y is equal to -3. So at the -3, we're going to make a horizontal line at the -3. So these lines are intersecting. That means that there is one solution. And the solution is the point where they intersect, so you're going to write -1, -3 as the solution. We're going to call this y1 because it was the first equation, and this one y2. Okay, so let's take a look at that again. We're going to graph the two lines, a +1, and then up 1 to the right 1 is your y1, the first equation. The second equation is -3, 1, 2, 3. And this would mean down 1 to the right 1. And I just did the opposite to make sure that I found that point of intersection. So this one was the y2 and this one was the y1, and the lines are intersecting. The point of intersection is this order pair right here that looks like it's -2, -1. Okay, to be consistent means that there is a solution, like there exists a solution. And dependent means that there's infinitely many. You can write infinitely many. Solutions. Or you can just say infinite. To say that there's infinite amount of solutions. Okay, so let's take a look at what those look like. Your first equation is ready to graph, so we're going to start at the -1. Going to go up 2 to the right 1. Okay, your y2 is not ready to solve, so we're going to rewrite it and solve for y. Don't forget to divide by that -1. So we start at the -1. Oh, sorry, at the -1. And this will go up to the right 1. We have the same line, so this is hard to denote that we have the same one. So this is what I would like for you to do. Write y1 for the first equation right here, and then write y2 for the second equation up there. So we can tell that both lines are on there. Since the lines are the same, then we got infinite solutions. You can also write infinitely many. Okay, so again, this is y1, the first equation is ready to graph. So we're going to start at the positive 5. 1, 2, 3, 4, 5. We need to go down 2 to the right 1. And this is your y1. The other one's not ready to graph yet, so we need to fix it. 2x plus y is equal to 5. So we're going to subtract 2x from both sides. Y is equal to negative 2x plus 5. You can tell that the lines are the same. If we graph it, we start at the positive 5, go down to the right 1, and they would be on the same graph. Like I said, it's difficult to see the difference, so you just make another one and say y2. And that means that there is infinitely many solutions or infinite solutions. All right, and then the last one is an inconsistent system, means that there is no solutions. So it can't be either independent or dependent because these lines don't intersect. So the first one is at negative 1. You're going to go up 2 to the right 1. On the next one, we're going to go down 2. Start at the positive 1. We already did that one. Sorry, I accidentally drew y2 first with the positive 1. So now we need to start at the negative 1. Now go down 2 to the right 1. Sorry, I keep messing this up. It's supposed to be from the negative 1 up 2 to the right 1. The reason that I kept noticing that I was messing up is because these are on purpose, that they're inconsistent. So this is y1. That means that they're parallel. These lines are parallel. And they have no intersection. That means they have no solution. You can also write none. So let's try that again. We have the first equation, when 3x plus y is equal to 4. We got to solve for y, so we're going to subtract 3x from both sides. Y is equal to negative 3x plus 4. And we're going to call this y1, the first one. So we start at a positive 4. 1, 2, 3, 4. We're going to go down 3. 1, 2, 3 into the right 1. And this is your y1. Then the second equation, I'm going to make a little separation for my work. I have 3x plus y is equal to negative 2. We're going to subtract 3x from both sides. Y is equal to negative 3x minus 2. And as you can tell, these lines are going to be parallel because they have the same slope. So these lines are parallel. And I graph it at the negative 2. We're going to go down 3, 1, 2, 3 into the right one. This is my y2. And since they have no intersection, then they have no solution.